Integer multiplication and matrix multiplication. Integer multiplication. Given two n-digit integers a and b, we have to compute a cross b. So if we apply brute force, there will be O of n square bit operations. So as you can see, for this 41 cross, if when we want to do multiplication of 41 cross 42, each number is 1 2 3 4 5 6 bits. So the order for multiplying two 6-bit number, the number of operations required is 6 square, that is 36 operations are required. Next is integer multiplication with d and c, that is divide and conquer. To multiply two n-digit integers, multiply 4 half n-digit integers, add 2 half n-digit integers and shift to obtain the result. So we can write t of n as 4 t of n by 2, that are recursive calls, and 1 O of n for add and shift. So it will be in the order of O of n square. Karatsuba multiplication algorithm. To multiply two n-digit integers, add two half n-digit integers, multiply three half n-digit integers, add, subtract and shift half n-digit integers to obtain result. So this was the theorem that he proposed in 1962, that can multiply two n-digit integer in O of n raised to the power 1.58 bit operations. So t of n is less than equal to t of floor of n by 2 plus t of floor of n by 2 plus t of 1 plus n by 2. All these are recursive call, and for n operations for add, subtract and shift. So when he calculated this, it came to be O of n log 3. So that is O of n raised to the power of 1.58. Integer matrix multiplication. Matrix multiplication. Given two n by n matrices A and B, we have to compute C, that is equal to A by A into B. So if we again choose the grade school approach, there will be O of n cube at arithmetic operations. Now how we do it? By divide and conquer. To multiply two n by n matrices A and B, divide, conquer and combine. These are the three steps, right? So divide, we will partition A and B into half n by half n blocks. Conquer, multiply 8 pairs of half n by half n matrices recursively, and combine, add appropriate products using 4 matrix add-ons. That is, you can see we have to multiply A and B. So C11 can be A11 into B11 plus A12 plus into B21. C12 is A11 into B12 plus A12 into B22, and so on. So for t of n, it is equal to 8 recursive calls, that is 8 t of n by 2 plus O of n square now for add form submatrices. So if we calculate, it will come to the power of O of n cube. So what is the better approach? Multiply 2 by 2 blocks with only 7 multiplication. So there will be 7 multiplication and 18 addition and subtraction. Strachan's algorithm. Procedure. Divide. Partition A and B into half n by half n blocks. Compute 14 half n by half n matrices via 10 additions. Conquer. Multiply 7 half n by half n matrices recursively. Combine 7 products into 4 terms using 8 matrix addition. So if we analyze this, so n will be some in power of 2. See, t of n will be 7 recursive call, that is 7 n by 2 plus O of n square for addition and subtraction. So if we calculate, it will be O raised to the power n raised to the power log 7 for base 2, and so the value of O is coming out in the order of n to the power 2.81. Thank you.